This is 8.3, Day 1, Part 2. We're continuing to add and subtract rational expressions. The ones that we've done so far on our lesson have like denominators. These two have unlike denominators. Please write this example down. So the first step is to factor the denominators to see what the least common denominator would be. The first fraction, there's nothing to do with the one on the left, so we just rewrite it as x over x minus 2. The one on the right can be factored in the denominator as the difference of two squares, x minus 2 and x plus 2. Now we want to find the least common denominator, so we want to get them to be alike. Well, the least common denominator is going to be x minus 2 and x plus 2, so I want them to be alike. So I need to increase this first fraction, the numerator and the denominator, by x plus 2. Now if I look at the two fractions, they are both alike. They both have the same denominator. So now I can go ahead and add the two fractions together. So I have x plus 2, and then this is a plus minus, so I'll just turn that to a minus 8, over my least common denominator of x minus 2, x plus 2. Again, I can only add fractions if they have exactly the same denominator. So now I'm just going to clean up that numerator. I'm going to distribute the x through, so it's x squared plus 2x minus 8 over x minus 2, x plus 2. Then we look and see if we can factor the numerator. So I look at the t-chart. Are there factors of negative 8 that add to 2? So I make my t-chart, factors of negative 8 that add to 2. 4 times negative 2 adds to 2. So we can factor that numerator as x plus 4 and x minus 2. And then the denominator is still that LCD, least common denominator, x minus 2, x plus 2. How that benefited us is we can go ahead and cross out a common factor, x minus 2 and x minus 2. So then what we're left with is x plus 4 over x minus 2. And then our domain restriction is x can't be 2 and negative 2. Remember, we're always looking at the denominator. That makes it undefined. So if I substituted 2 or negative 2 into this fraction, it would make it undefined. Let's go on to another example. Here's a set of two fractions. They are unlike. So we're going to go ahead and factor the two fractions. The first fraction on the left is factored. Nothing you can do with it. The second fraction can be, again, factored using the difference of two squares. So I'm going to keep the first fraction as it is. I'm just going to leave a little space. And over here is negative 50. Factor the difference of two squares, x minus 5, x plus 5. Well, if I look at the two fractions right now in the denominator, they're not alike. The one on the right has an x minus 5 and an x plus 5. So I have to increase the left fraction, the numerator and the denominator, by x minus 5. Now if I look at the two fractions, they're exactly alike. So I can go ahead and add these two fractions together. So now I have x minus 5 plus negative 5, or negative 50, over x minus 5, x plus 5. Now I'm going to clean up the numerator, so I'm going to distribute the x through in that parentheses. So I get x squared minus 5x minus 50 over x minus 5, x plus 5. Now let's see if that factors. Are there factors of negative 50 that add to negative 5? Negative 10 times 5 is negative 50. I add it, I get negative 5, so it is factorable. This is the t-chart. So it looks like x minus 10 and x plus 5. And then the denominator is still the same, x minus 5, x plus 5. And now I look to see if there's a common factor that can cancel out. There is. The x plus 5s are a common factor, so those will cancel out. So I'm left with x minus 10 over x minus 5. And again, we want you to identify that domain restriction. What can x not be? So we look at this denominator. If I substitute 5 in, or negative 5 in, it would make it undefined. They would be zeros. Last example. Subtract these rational expressions. So we want to first factor their denominators if they are possible. In this case, there's nothing to factor. So the least common denominator is both of the denominators. So the first fraction, I need to multiply the numerator and the denominator by this 2x plus 5. And then the fraction on the right, I need to make those to be alike with the left. So I need to multiply it by 3x minus 1. Now we look at the two fractions. Are they alike? No. Yes, they are. So we can go ahead and subtract them. So I have 6x, 2x plus 5, minus 4x, 3x minus 1, and then that denominator. I think I just lost my connection on my smartboard. All right, so ready? 2x plus 5 over 3x minus 1. So I need to clean up that numerator. Oh, what's the wrong way? So I'm going to distribute the 6x through this first parenthesis. So 6x times 2x is 12x squared. And then 6x times 5 is 30x. I'm going to distribute the negative 4x through, so I get negative 12x squared, and then plus 4x over that LCD of 2x plus 5 and 3x minus 1. Now I look to see if there's any like terms. In the numerator, well actually the 12x squared and the negative 12x squared will cancel. And then we have 30x plus 34x. 4 is 34x over 2x plus 5 over 3x minus 1. And there's our final answer. This will be the assignment for 8.3 day 1 on page 588, 2 through 4, 7 through 12, 17 through 19.